All right, so let's start with number 1. They want us to do a confidence interval. They tell us that we have 34 hits, so that I go to my graphing calculator and I put in 34 out of 100 seniors, so that's my sample size. And I have a 90% confidence interval. And it goes from 2.6 to 4.2. So that is C. All right, so let's go to number 2. And here we're talking about a 95% confidence interval. Now they want us to compute a 99. All right, so let's talk about this. If 95 has a critical value of 1.96, what does 99 have? All right, so what am I going to do? I'm going to do 1 minus 0.99 divided by 2, and I get 0.005. So I'm going to go to inverse norm, put in 0.005, and I get 2.58. Now the standard error, 58, is the same for both of these. It's the same for both of these, right? So do you see how 2.58 is bigger? So therefore that means my margin of error is going to be bigger, and therefore my confidence interval is going to be wider. So the answer is B. Okay, let's go down here to number 3. It says a 95% confidence interval. The working place is this. They want us to find the sample proportion. And so remember what we have. We have a lower bound and we have an upper bound. And we have our proportion here. So to find this, I have to take these two numbers and I add them up and divide by 2. So 0.5527 plus 0.3827. 4 is 5 is 3 is 9. Okay, now I divide that by 2. So 0.9354 divided by 2, and I get 0.4677. All right, so that's the answer of C. Okay, so here they ask for which one is the formula for standard deviation. And for one proportion, it's this guy right here, because remember 1 minus P is equal to Q. All right? So let's go over here to number 5, where they want us to find the standard deviation. So I get 58% of 100. So to find the number of hits, so it's 0.58 times 100. Excuse me, I don't need to do that. I just got to get my p hat. Silly goose. So it's 0.58 times 0.42 over 100. Now you take the square root. 0.58 times 0.42 divided by 100. And I get 0.049. Okay, let's go to B. Here we get 673, so 0.673. 1 minus 0.673 divided by 230. 1 minus 0.673 gives me 0.327 times 0.673 divided by 200. And you take the square root of the number, and I get 0.033. Okay, let's go to number 6. According to Fisherman's Market, residential phones are on list to find the margin of error. All right, so hopefully you remember that this is my upper bound and this is my lower bound. This is 0.53. All right, let me think about this right here. Okay, Schwartz. I want to find the margin of error. Okay, so the problem is here, find the margin of error is equal to my critical value times p hat q hat divided by n. Okay, I can do all of that. I can't do my critical value because I didn't say at a 90 degrees confidence or anything like that. So we can't do that. But let's say it says 94%. Okay, let's do this problem anyway. Let's say it says 94%. Okay, so I need to find out what my critical value is. So 1 minus 0.94 divided by 2, and I get 0.03. So my distribution of 0.03, and I get 1.88. So it's 1.88 times the square root of 0.5345 times 1 minus 0.5345 divided by 312. So 1 minus 0.5345 times 0.5345 divided by 312. And you take the square root of that number, and I get 0.028. So I'm going to times that by 1.88, because that's my critical value, and I get 0.0543. Okay, here is they want us to do a 90. They want us to find the standard error. Okay, let's go do this problem on another page. 36 to 48, 90. 0.36. Okay, let's go do this. Here's my lower bound. Here's my upper bound. And this is 0.36. This is 0.48. Here is my p hat. Here's my margin of error. Here's my margin of error. Okay, so what I'm going to do is going to find p hat. So I'm going to take 0.48 plus 0.36 divided by 2, and I get 0.42. So to find my margin of error, is 0.42 minus 0.36, which is 0.06. And we know that margin of error is equal to my critical value times my standard error of p hat. Okay, let me change to another color. This is what they want me to solve for. So I need to get that by itself. But first I know what all my values are, because I know my margin of error, 0.06. Okay, 90%. So I'm going to do 1 minus 0.9 divided by 2, and I get 0.05. An inverse norm of 0.05. Get 1.64. times my standard error of p hat. Okay, so I'm going to put in 0.06 divided by 0.04, and so I get my standard error of p hat is equal to 0.035, and that's my standard of error.